Well, we've done a little bit of work with probabilities so far, and mainly sample space, and then looking at that sample space and trying to determine probability of an event happening. We've mentioned experimental probability, but today we're going to get a little bit more into it. Okay, so here we go with an example. When a member of the opposing team fouls a basketball player who is shooting, the player shoots 2 free throws. And anybody that knows a little bit about basketball, you kind of understand what we're talking about there. Near the end of a close game, a player has made 6 out of 20 free throws, and he has made 60% of his 2 point shots. When the player has the ball in 2 point range, should the opposing team foul him or risk the shot? Okay, there's probably a lot of other issues that go into this, but looking at it very simply, should we let him shoot a 2 point shot, which he's 60% makes 60% of, or should we make him shoot free throws, um, by fouling him? So 6 out of 20 on free throws. That's his experimental probability. Okay, um, you can't look at free throws as if, okay, you can either make it or you can miss it. That's true, you can make it or miss it, but some people make a lot more than they miss. So um, it makes sense to use experimental probability here. So I've got the answer over here. Okay, the probability um, that he makes of making a free throw would be 6 out of 20, which is 30%. Okay, the probability that he makes a 2 point shot, they flat out gave us, they said it's a 60% chance. So I think the answer is pretty obvious. We should foul him. Okay. The reason being that the probability that he makes both free throws and actually gets 1 point for each one of them, totaling 2 points, it's actually less than 30%. The probability that he makes one free throw is 30%. The probability that he makes both of them is going to be less than 30%. So we'll get into that a little bit more later. Okay, Quinn runs a sandwich shop. Since she added a turkey melt to the menu, 36 out of the 120 customers have ordered the new sandwich. What's the probability that the next customer will order a turkey melt? Okay, well, out of the 36 out of the 120 that have come in have ordered the turkey melt, so that comes out to a probability of 0.3, or we could say 30%. You could also say 3 out of 10. 3 out of every 10 people that'll come in. Oops, excuse me. Quinn ordinarily has 200 customers on a busy afternoon. About how many turkey melts should she expect to sell? Okay, well, we can take those 200 people um, and just multiply it by the probability that each one will buy a turkey melt, and that'll tell us about how many people we can expect to buy turkey melts. So I'm going to change that 0.3 or 30% to 3/10, and it'll tell me that about 60 customers could be expected to buy turkey melts. 3 out of every 10, 30 out of every 100, and that's pretty obvious right there. 30 out of every 100, so that would be 60 out of every 200. 60 customers. So that's using experimental probability to kind of predict the future a little bit. All right, to prepare premium rates, the amounts customers pay, that's what a premium rate is, for an insurance plan, an insurance company conducts an extensive risk study to determine the probability that a member of a certain group may require a payoff. Based on these probabilities, the expected amount of payoff is charged to the customer as part of the premium. Explain why car insurance companies charge a higher premium for teenage drivers with a clean driving record than for adult drivers with a clean driving record. So neither one have ever got into an accident before. Why do they charge teenage drivers more than adults? Well, it's pretty simple. Insurance companies charge teenage drivers more. Because their studies show that teenage drivers, or show that they, teenage drivers, have a higher probability of getting into an accident. So even though this one particular person who's getting charged may have never been in an accident before, because teenage drivers in general are more likely to get into an accident, and that's what probability is, a measurement of likeliness, then the insurance company is going to be better safe than sorry, and they're going to charge teenage drivers a little bit more. Megan is a 50% free throw shooter. Select a model to simulate a game in which Megan shoots 10 free throws. Well, there's lots of different models we could choose here. But I guess, I mean, if she's a 50% free throw shooter, that means for every one that she makes, she also misses one. So what else could we select that has a 50% chance of something happening? And hopefully you guys are kind of looking at it and saying, well, obviously flipping a coin has got a 50% chance of coming up heads and 50% chance of coming up tails. So how about we just go with that? Flip a coin 10 times to simulate Megan taking 10 free throws. Flipping a coin and having it land heads is the same probability as Megan making a free throw. Okay, so we could simply just let heads represent a make, tails represent a miss, or vice versa. Do it 10 times, and there we go. Okay, it wouldn't work if she was a 40% free throw shooter. We'd have to figure something else out then, but it does work if since she's a 50% free throw shooter. Okay, so it's a little introduction to experimental probability and how we can use it to predict the future and predict likeliness that something's going to happen. And good luck with it, and we'll practice in class. Have a great night.